Hello friends, I'm Deepak from TechPex. Today I'm here to share the project details for the automatic lane detection system. So this is basically an computer vision based and artificial intelligence based application. But this is not totally the software rented application. So we are embedding an hardware and designing a prototype car which will be mounted with a camera on it, and that will detect the lane and detect that whether the vehicle is within the lane or it is changing itself. It is basically a project in which if a person who is driving, if it is intentionally changing the lane, then it will not detect the lane change. Else, if it is automatically get changed the lane without giving any indication by the driver, then it will give an alarm to the driver so that the accidents can be avoided. For that, we have designed the hardware in which we have used a number of components which I am giving you the detail one by one. So to design that particular hardware, we need certain components including one LCD. It is a 16 by 2 LCD. This is a buzzer just to alarm the driver in case the lane is automatically get detected. This is basically the resistance that we do need to run the certain components. Few of the LEDs that we need to demonstrate that the indicators are given by the user itself. A general purpose PCB on which we can design the circuit if we want to design by our own. A variable resistance which is useful to control the voltage given to the different components. A set of wires that can help us to connect the components. A Raspberry Pi board, because we are designing the board which is basically a standalone application, but here for the demonstration purpose we will show you with the computer so that you can see that how the code can be done and how the things can happen. Other than that, the developed code can be run standalone on the Raspberry Pi. For connecting the LCDs and all, we have used the connecting slot. Other than that, we do need a double tape for mounting the things, a camera which can help us to visualize the track on the road or the prototype that we are going to design, a chassis. As you can see, here it is a chassis on which we have mounted 4 wheels. These are the free wheels and a camera which is mounted over it. So before starting it, I just want to connect all the components and can show you a set of connections that how it can work and what exactly the working of them. So now further to this, you can see we have connected all the components that I have shown you earlier, and as you can see the 4 LEDs, those are behaving as an indicator. One camera that is having the USB connector. You can skip the point of this audio one because we don't need the audio processor. So here the camera that I am using. Along with that, we have a connector through which we have connected the LCD that we are going to connect with the Raspberry Pi. A buzzer which will beep. These are the free wheel rotating chassis that we have designed. So this is the Raspberry Pi board that I have earlier shown. You can see there are certain ports over it, these USB ports. Other than that, for GPIO pin users, here you can use 32 GB micro SD card is used for the OS system, and rest of the power supply and other connections can be done over this controller. So you can see what we are going to do. We are just connecting these LCD wires and other components, and on the USB we are connecting our camera. So here you can see this is how I can make the connections. So here is a buzzer. You just need to take care that everything should be placed in a proper way. So let me give you an overview that what exactly we have did. Here is the LCD. As you can see, here's the LCD on which the message will be printed. These LEDs are basically the indicators. Those will be controlled by using these 2 buttons. This is for left and this is for left and this is for right. This is the Raspberry Pi board, this is the buzzer, and this is basically the variable resistance that we use to control the LCD brightness and all that stuff. And this is a camera. And also along with that, you can see we do have this black chart with us on which I can show you. I have drawn 2 lanes with a white color over it. So here you can see. So you can directly go to the roads also, but as we are demonstrating the prototype, we just need to do it in the indoor. So that's why we have just taken a black chart with the white stripes drawn over it by the manual procedure. So let's start with the demonstration of this prototype. As you can see, currently we have not connected any of the monitor to it so that the visuals can be seen on the screen. we will show that in the another section of the demonstration. Right now you can see we have just given the power source to the controller, to the Raspberry Pi, and right now it is in between two lanes. So two lines are on the both side of the model. So currently it is detecting both the lanes, both left and the right one. So you can see the status of the lane detection, or the status of the vehicle is currently normal. You can see the visuals on the LCD. So I'm going to move this vehicle to the forward direction so that we can see when it is moving within the lane, then what will be the decision, and what if we are moving it to the left or the right lane without giving the indicators. So let's see. I'm just moving it to the forward direction, so it is still detecting the lanes. Now I'm moving to the left side of the road. So you can see, as you can see, I just changed the lane and no indicator was given. You can see the message given over the LCD is lane change detected, and L means left, and even the lane you can see only the tire is in the other direction. So I'm just coming back to the lane and moving it forward. So you can see once it will be in the lane, the detection is again normal, right? So I'm coming back just to demonstrate that what will happen if we will move toward the other direction. So you can see still the status is normal. Now let's move to the right direction and see what exactly will happen when it will change the lane. So I'm moving forward, both the lanes are okay. So as I move to the right, on the right is detected, and you can see here the lane change detected for the R. Now I'm going to the center again. Now as it is back to the lane, so you can see it is again the normal. So let's do the same task while giving the indicator. So I am giving the left indicator. You can see the lights get on here, the indicator get on, and now you can see here the left lane active. So when I'm moving to the left side, it is active, so there will be no alarm. And if I'm coming back and the indicator will be off, you can see the status is again normal. So this is how, if the indicator will be given and the lane detection will be there, so there will be no alarm, but lane active will be shown here. If the lane change detected but no indicator is given, it will alarm the driver that there is a automatic lane change detection. So now we will see if I'm moving in the right lane with giving the indicator, so whether it is giving the alarm or not. So you can see I'm moving forward, giving the indicator get on, and if I'm changing the lane, there is no indicator, right? So I'm coming back and coming within the lane and switching off the indicator, and you can see the status is normal. Next to it, to show that what exactly is done in the Raspberry Pi, we do need some additional things like HDMI converter if you don't have the HDMI cable direct one, an optical mouse, and one keyboard. So as you can, I have connected all the modules like the mouse, a keyboard, and one screen, so that we can see that what exactly is happening within the Raspberry Pi. So we just need to give the power supply to it. So I'm connecting the adapter to the power section of the Raspberry Pi. As the power will be given, you can see the lights start blinking here, and this LCD get yellow as the power is given to the whole module. So the Raspberry Pi is get booted, and whatever the OS we have embedded to this particular Raspberry Pi will be shown here. This is the Python file that we have developed. Here is the code. So we just need to open it, and it will be shown like this is the folder that opening, and the file name test will get opened. So as I am opening it, this is basically the Python code which is having certain modules in it. So till now here nothing is visible on the code. So firstly let's have the demonstration of it. As I'm running the code, you can see the LCD will print real-time lane detection system. As the code is running on the Python script, you can see here the lanes are getting visualized, as the camera that we have mounted on the top of it is capable to see these two different lanes which are behaving as a road for it. One more case is there. In the case there is no lane detected, for example, I am placing the hand in front of the camera, you can see the message shown is no lane is detected, no lane is active, nothing is visualized, and even the camera is. So once I again just process it, both the lanes are visuals and the status is normal. So this is how, by using the technology, we will be able to automate the machinery and can use it in many certain real-time application areas. I hope you people like this video. For such more videos, subscribe our channel and press the bell icon. Thank you for watching the video. This is the whole application that we have demonstrated as an automated lane detection system with the alarming system. Thank you.